Our Chapter 9 test review covers these pages 550, number 68 through 68 through 80 even. I said 870 because this is what covers Chapter 8, Section 7, and then this will cover everything in Chapter 9 that we did. So let's begin back with factoring special products, which is Chapter 8, Section 7. So what we see here in number 68 is a difference of squares. It's just two terms, they're being subtracted, and they're both perfect squares. So to factor this, you take the square root of the first term, which would be y, the square root of the second term, which would be 9, and that tells you what to put in both places. And then you just put one of them as a positive, one of them as a negative, or one as a plus, one as a minus. And it doesn't matter one bit whether you put the plus first and the minus second, or vice versa. Okay, 16 a squared minus 21b squared. Now this at first appears to be the same kind of problem, difference of squares. It is just two terms and they're being subtracted. And you can take the square root of 16, that's 4, square root of a squared, that's a, but we cannot take the square root of 21, or it's not a perfect square. So the reason it's called difference of squares is they have to be subtracted, difference, and they have to be perfect squares in order for this to work. So this one we'd actually just say is prime. So if they are not both perfect squares, we say prime. 72, we have a squared minus 25. Okay, this one, they are both perfect squares, so we do what we did on 68. Square root of a squared is a. Square root of 25 is 5. We do one of them as a positive and one of them as a negative. It doesn't matter which one comes first or second. Okay, now there are some shortcuts for the rest of the ones we're going to do from this section, but we chose to just do them the normal factoring way that we learned in previous sections. So instead of worrying about memorizing some crazy formula that's far more complicated than difference of squares, we'll just do the normal factoring. We say, okay, what will multiply to be 36 and add up to 12? Well, that would be positive 6 and positive 6. So I'll do x plus 6 and x plus 6. Now in this section of factoring, you will see the same thing occur. Now up here, one was positive, one was negative, but otherwise they're identical. The rest of these we do, they'll almost always be the exact same term each time. So you can write the answer this way. You could also write the answer this way. Either one is fine. 76, we have 9y squared minus 12y plus 4. Sorry, no need for that parenthesis. That's a 4. There's nothing all three have in common, so we do the bottoms up method. 9 times 4 is 36. So we got to figure out what multiplies to be positive 36 and adds up to negative 12. And that would be negative 6 and negative 6. So we start by writing y minus 6 and y minus 6. But that 9 we tried to get rid of by combining it with a 4 now comes back and tries to divide and conquer us. But make sure you reduce this fraction before you do the bottoms up. So we change this to 2/3 first, then we move the bottoms up. You get 3y minus 2 times 3y minus 2. (78) x to the 4th minus 1. So this is actually difference of squares again. We have just two terms. They're subtracted, difference, and they're perfect squares. The square root of x to the 4th is x squared. The square root of 1 is 1. We make sure one of them is a minus, one of them is a plus. However, what you need to see is we actually have a difference of squares showing up again. Now this term is all done. We're adding, not subtracting, so there's no difference. They're both perfect squares, but it's not a subtraction, so it's not a difference. But these two are. Square root of x squared is x. Square root of 1 is 1. Square root of x squared is x. Square root of 1 is 1. We do 1 plus and 1 minus. Then don't forget this term. This term doesn't disappear. It just doesn't change any more than what it did at the beginning. Okay, then number 80, 9x squared plus 25. Well, this has two terms, which makes us think of difference of squares, and they are perfect squares. 9's a perfect square, x squared's a perfect square, 25 is a perfect square, but we're not subtracting. So this is not a difference of squares, this is a sum of squares, and there's no factoring for those. It's only the subtraction or the difference of squares. So just like on this one, we had to say prime because this was not a perfect square. On this one, we have to say a prime because even though they are perfect squares, we're not subtracting. Okay, now let's transition over to our questions on page 638 and following. This is the stuff for chapter 9. Okay, so number 12, we have the equation y equals negative 3x, I don't know why I said that, negative x squared plus 3x. And you only need to do part A and part B on this. Determine whether the function has a maximum or a minimum. That's part A. So for part A, it would have a maximum because when the x squared term is negative, that means it's shaped like this, so it'd have a maximum. Then part B asks us what are the domain and range of the function. No, sorry, I'm having trouble reading the right things. My apologies. B says state the max or minimum value, which in our class I want you to tell me the x value for where that occurs. So we have negative b over 2a is how we find that. B is the coefficient in front of x, so that's 3. A is the coefficient in front of x squared, which is negative 1, so we get 2 times negative 1. So again, A is the coefficient in front of x squared, B is the coefficient in front of x. So we get negative 3 over negative 2, which we can just change to 3 halves. So x equals 3 halves is where the maximum will occur. Okay, 14, same process. We have y equals negative x squared plus 2. So first of all, it would have a maximum because the x squared term is negative, so that means the parabola is shaped this way, so it's a maximum up here. Then to find out where this maximum occurs, we do negative b over 2a. Now here's where we have to be careful. The general form for a quadratic looks like this. Like I said, a is the coefficient in front of the x squared, b is the coefficient in front of x, and then c, which doesn't come into play here, is the constant, the number with no variable. Okay, so as you look at this, a would be negative 1, just like it was in number 12. But there is no x term at all. 2 is the c value, not the b. There's no x term at all. That means there's 0 x's, so b is 0. Now you can write negative if you want, but negative 0 doesn't really mean anything different than just 0. So we get 0 over negative 2, which is 0. So this maximum for this graph would occur at x equals 0. Okay, for the rest of these questions, we're going to be trying to solve the quadratic equation, but we're going to use different methods to do it. On 32, we're trying to solve the quadratic equation by factoring. So 32 says g plus 8 squared equals 49. We take the square root of both sides, and we get g plus 8 equals plus or minus 7. Then we subtract 8 from both sides. We get g equals negative 8 plus or minus 7. Now I'm content with this answer. This is great. But if you want to go ahead and solve this, you could say negative 8 plus 7 is negative 1. Negative 8 minus 7 is negative 15. So I would accept either one of those as correct answers. Okay, 34. 3k squared minus 8k equals 3. So this will be our other method. This one we just had a single term with a variable, so we could just try to get it by itself with some square roots. But we have two terms with a variable here, so we'll need to do the normal factoring method. We called it type 2 in the notes. So the first thing to do in that style is to get this equal to 0. So we'll subtract 3 from both sides. Then we check, there's nothing all the terms have in common, so we'll use the bottoms up method because of this coefficient in front of the k squared. So we get negative 9. So we got to think what will multiply to be negative 9 and add up to negative 8. And that would be negative 9 and positive 1. So we get k minus 9, k plus 1. But then this 3 in front that we try to get rid of by combining it with this 3 comes back, seeks to divide and conquer. This reduces to k minus 3. This we have to bring the bottom up, and we get 3k plus 1. So our final step is to then set both of these equal to 0 and solve for k. So on this, we'd add 3 to both sides. So one of our solutions is k equals 3. Here, we'd have to subtract 1 first. Then divide both sides by 3, get k equals negative 1/3. So we get k equals 3 and k equals negative 1/3. Okay, on 36, still using the same method, we are solving the quadratic equation by factoring. We have 4w squared plus 9 equals 12w. Just as it was in the previous problem, 34, the first thing we want is to get this set equal to 0. So I'll need to subtract 12w from both sides. And just because it usually is, I'm going to put the w term in the middle. So we get 4w squared minus 12w plus 9. There's nothing all three terms have in common, so I'll use the bottoms up method. 4 times 9 is 36. I got to decide what multiplies to be 36 and adds up to negative 12. That would be negative 6 and negative 6. So I get w minus 6, w minus 6. But that 4 that we tried to make disappear by multiplying it and combining it with a 9 comes back, seeks to divide and conquer. Don't forget, before you bring the bottoms up, you must reduce. So this reduces to 3/2. Then we bring the bottoms up. We get 2w minus 3, 2w minus 3 equals 0. Now hopefully you can see, since these two terms are equal, we don't have to set them both equal to 0 because they'll both give us the same result. So we can just set one of them equal to 0, add 3 to both sides, and divide by 2. So we just get one solution, and it is w equals 3/2. Okay, now we're going to transition to a different method of solving quadratic equations, and that is completing the square. So on 38, we have negative a squared minus 10a plus 25 equals 25. So with completing the square, you don't need it set equal to 0 to start with, but you do need two things. You need the squared term to be positive, and you want all constants on the different side than the terms with variables. So you could do it in either order. I'm going to subtract 25 first. That way I have just variables on one side and just constants on the other. And hopefully you know this, but it's not common that it just goes to 0. It can happen, obviously, but you'll often have a number other than 0 over here. Then I'm going to multiply everything by -1, so I can get that to be a positive a squared plus 10a equals 0. My fault. 0 times -1 is 0. So we have to complete the square. To do that, we look at the b term, the coefficient in front of the linear term, the a. We cut this in half. Half of 10 is 5. Then we square it and get 25, and we add 25 to both sides. Then we need to factor this. So we think what multiplies to be 25 and adds up to 10, well, that's going to be plus 5. So we get a plus 5 times a plus 5, which can be written as a plus 5 squared. Then we take the square root of both sides and get a plus 5 equals plus or minus 5. Then to get a by itself, we'll subtract 5 from both sides. And we get -5 plus or minus 5. And I would accept the answer this way, or since it's all whole numbers, or I should say integers, you could say, well, -5 plus 5 is 0. -5 minus 5 is -10. Number 40, we'll also be completing the square. I have y squared minus 6y plus 2 equals 0. So the squared term is positive. That's good for us. But we do want the constant to be moved over to the other side. So y squared minus 6y equals -2. Okay, then we cut the -6 in half. That's -3. Square it, that's +9. And add that to both sides. Y squared minus 6y plus 9 equals 7. Then we need to factor this side. So we got to think what multiplies to be 9, positive 9, and adds up to -6. That would be -3. And as you hopefully know, the reason we call it completing the square is these are always going to end up the same. So I'm probably going to skip this step next time and jump straight to where it's whatever the term is squared. Then we take the square root of both sides and get y minus 3 equals plus or minus the square root of 7. Then we add 3 to both sides. Get 3 plus or minus the square root of 7. Okay, 42. -3x squared plus 4 equals 0. So we want to get this term, the constant over to the other side, so we'll subtract 4 from both sides. And we want the squared term to be positive, so we'll multiply both sides by -1. Gives us +3x squared equals +4. Then there are other ways to solve this, but since we're told to do it by completing the square, I'm going to use that method. Actually, no, I don't think there is a way to use completing the square here, now that I say it. So let me back up just a second. If you look at our previous examples with completing the square, there was always a linear term. Like this is the quadratic term because it has the squared. This is the linear term because it has the variable to the first power. Same here, we have a linear term, but this had no linear term. So we don't need to do any completing the square on this one. We can just divide both sides by 3. And then take the square root of both sides. So we get x equals plus or minus the square root of 4/3. And these are enough work already. I think I'd probably take full credit for this. All right, I'd give you full credit for this, but technically we should go farther. The square root of 4 is 2. And we don't want to leave a square root in the denominator, so we'd have to multiply the top and bottom by the square root of 3 and get 2 square root of 3 over 3. So that is the best answer, but I'm pretty sure for the sake of your test, I'd give you full credit for that as well. Okay, just one more in the completing the square category. We have 2a squared minus 4a plus 1 equals 0. The squared term is positive, that's good. We want to get the constant over to the other side. 2a squared minus 4a equals -1. We do have a linear term, so we cut that in half, cut the coefficient in half to be -2. Actually, hold on, I'm sorry, I forgot something here. So one other thing we need, my mistake. We don't want to complete the square with this coefficient here. So we need to divide everything by 2. So a squared minus 2a equals -1/2. So requirements for completing the square are the a squared has to be positive, needs to have a coefficient of 1, and the constant is over by itself. Now we're ready to complete the square. We cut this in half, it's -1. Squared is +1, so we add 1 to both sides. That gives us a squared minus 2a plus 1 equals +1/2. And I'm transition up here. So we got to figure out what multiplies to be +1 and adds up to -2. That would be -1 and -1. So we get a minus 1 squared equals 1/2. We take the square root of both sides. We get a minus 1 equals plus or minus the square root of 1/2. Then we add 1 to both sides and get a equals 1 plus or minus the square root of 1/2. And our book gives the answer in decimal form, so just before I move on, I'm going to double check and make sure I'm not misleading you on that. Good news so far. Good, okay, yeah, that is correct. I know this is long, but we've got one more section to cover. I can get that, there you go. And that is using the quadratic formula. Just 3 of these. So starting with 46, we have x squared minus 8x equals 20. So similar to what we had in factoring, we need this to be equal to 0. We want this to be in standard form. So we'll subtract 20 from both sides. So it's in the ax squared plus bx plus c form. In other words, we have the x squared, the linear term, and the constant equals 0. And then a is the understood 1, b is -8, c is -20. And we do -b plus or minus the square root of b squared minus 4ac all divided by 2a. So we'll take all that fun stuff and put it in. So I have a -8. That will cancel out to be a positive, but we'll get there in a minute. negative 8 squared. A is 1, C is negative 20, and we divide all that by 2a. So I know I did that kind of quickly, so I'll break there just a moment and make sure you can write all that down if you want to. So these two negatives cancel out, making it a positive 8. Negative 8 squared is 64. And then negative 4 times negative 20 is positive 80. That's all divided by 2. Okay, 64 plus 80 is 144. The square root of 144 is 12. And those are both divisible by 2, so we can rewrite that as 4 plus or minus 6. So I would accept 4 plus or minus 6, but you could also say 4 plus 6 is 10, 4 minus 6 is negative 2. So you could write the answer either of those two ways. (48). We'll do the same process using the quadratic formula, and hey, look, this one, nice enough, is already in standard form. So our A is equal to 1, our B is equal to negative 5, our C is equal to positive 6. So A is the understood 1 in front of the D squared, our B is the negative 5 in front of D, and our C is the constant 6. So negative B plus or minus the square root of B squared minus 4AC all over 2 times A. The two negatives become a positive. Negative 5 squared is positive 25. 4 times 1 times 6 is 24. So we get 5 plus or minus the square root of 1, all divided by 2. The square root of 1 is 1. So I would accept this answer, I'd accept this answer right here. You could just say x equals 5 plus or minus 1 over 2. Or you could say 5 plus 1 is 6. 6 divided by 2 is 3. 5 minus 1 is 4. 4 divided by 2 is 2. So you can give me this answer or this answer. Okay, last one. 2h squared plus 8h plus 3 equals 3. We want this in standard form, so we need this to be 0, so we'll subtract 3 from both sides, giving us 2h squared plus 8h equals 0. Now, we do want this, if there's anything that all of them have in common, we should get rid of it. So if you notice, these are both divisible by 2, so we could just divide everything by 2 and get h squared plus 4h equals 0. You want to get rid of anything they all have in common, or else it causes some problems with the quadratic formula. Nobody wants that. So a is equal to 1, because it's the understood 1 in front of h squared. B is equal to 4, because it's the coefficient in front of h. C is equal to 0, because there is no constant. It disappeared, so there is no constant at all. So we have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. On top we have negative 4. 4 squared is 16. 4 times 1 times 0 is 0. And 2 times 1 is 2. So, sorry, that's 16 minus 0, so that just turns into 16. Square root of 16 is 4. And these are all divisible by 2, so you should divide it all by 2 and get negative 2 plus or minus 2. So I would accept this answer. That'd be fine. Or you could say negative 2 plus 2 is 0. Negative 2 minus 2 is negative 4.